Hey guys, so you see the title here, function notation. In the last lesson we were talking about functions and how to look at the inputs and outputs in order to tell if a relation is a function. Now this is simply, well, it's doing a few things, but one of the things, the main things, is just being comfortable with using function notation. So my essential question here, how do you write y equals x in function notation, right? So that's definitely something you'd want to know by the end of this lesson, and a few more things. Function notation is really just a fancy way to write an equation. So right here it says f of x equals 2x plus 5. The way you read this is f of x. It's the same as y equals 2x plus 5. The letter f is the name of the function x. As I stated, you read fx as f of x, or f is a function of x. Other letters can be used instead of f. For example, g or h. So here I would say g of x equals x squared, right? Again, g of x. Here, h of x equals 2 times 8 to the x power. And then at the beginning, it's just write these in function notation. So all I have to do is change y to f of x, right? Each equation in function notation. All I have to do again is change y to f of x, and I've now written it in function notation. So it is as simple as that for changing these equations to function notation. Y equals negative 4x, f of x equals negative 4x. And again, all you do is change y to f of x, or if you want to use a different letter, if you want to write like the one up there, g of x, right? You can use a different letter instead of f. So g of x equals negative 2x squared. So you could use f of x, g of x. Really, you could use any letter you want. H of x. Right? So I'm just kind of advising that all you need to do is change y to function notation. It really doesn't matter which letter you choose. H of x equals 3 to the x power plus 4. That's all we had to do on those. Again, if you see fx equals 2x plus 1, then you say f of x equals 2x plus 1. Now, the next part is just substitution, guys. It's substitution, and so they want me to calculate basically it's 3 goes into the function. Think about like a function machine or something. 3 goes into the function, and what comes out, right? So in this case, f of 3 would be 3 times 3 plus 5. So basically, anywhere I see an x, I'm plugging in a 3 in this problem. And then I'm only really calculating on the right side. The left side is just notation. The left side is just saying, you're putting 3 into this function. Tell me what comes out. So the left side is just notation, and the right side is where I actually do the work. So f of 3 equals 9 plus 5. Right? 3 times 3 is 9. And then 9 plus 5 is 14. Moving right along, same thing on this one. F of 4 is simply asking me to plug in a 4 anywhere I see an x, and all I do is work on the right. 4 times 4 is 16, and 16 minus 3 is 13. So the f of 4 equals 13. Again, when I plug a 4 into this function, a 13 comes out. 4 is the input, 13 is the output. So hopefully that is all good. Again, just plugging in numbers and calculating. All the work is happening on one side of the equation. Calculate g of 4 and g of 3 for g of x equals 3 to the x. Well, careful with these because, so first g of 4 equals, remember I'm using this function here, g of 4 equals 3 to the 4th. Just be careful because you did plug in an exponent, so that means 3 times 3 times 3 times 3. Okay, use a calculator if needed. It's 81. And then it also says to calculate g of 3. Well, I pretty much, by doing g of 4, I already know what g of 3 is, but just to make a note of it. G of 3 would be 3 to the 3rd power, and 3 times 3 is 9, times 3 again is 27. So there's that one. Evaluate a function for a given domain. So I'm going to calculate f of 3 and f of 7 for this function. So again, it's two separate calculations. It's what do you get when 3 goes into the function, and what do you get when 7 goes into the function. So it really is just substitution, but one of the main points is getting you comfortable with using function notation. So for f of 3, it's going to be 2 to the third, which is 2 times 2 times 2, so f of 3 is 8. And then f of 7 might be a little more of a pain. I want to use a calculator. F of 7 is going to be 2 to the 7, and that's 2 times 2 times 2, obviously 7 times, so 1, 2, 3, 4, 5, 6, 7, and you can use a calculator, or you can probably do this one, mental math. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 again is 128, so f of 7 equals 128. This next one, calculate g of 4 for this function here, and then g of negative 5. So g of 4 squared minus 10 is what we will get. And 4 squared is 16, and 16 minus 10 is 6. So there's that. And then g of negative 5 equals negative 5 squared minus 10. And then you do have to square the negative number, but remember, a negative number times a negative number is positive, so positive 25 minus 10, 15. So g of negative 5 is 15 on this one. So this next part does require at least a knowledge of how to graph points. Again, if you know how to graph points like x and y, right? If you know how to graph, like, again, just going to give you an example. If you know how to graph 2, negative 1, actually 2, negative 1 is on this graph. It's 2 to the right and 1 down. Right, it's here. So x is 2 and y is negative 1. And then you need to know this, that f of x is aka y. So the ones that are saying find the value of x when f of x equals negative 1, this is basically the same as saying what's x where y equals negative 1. So you got to be able to find these locations of x and y anyhow. What is f of negative 2? Well, go to this one is x, so x is negative 2. So if x is negative 2, it's here, and what is y where x is negative 2? Well, here's where x is negative 2 and y is down here, so y is negative 5 at that point. So I just have to find these locations accurately. Find y where x equals 1, right? What is f of 1? Well, here's 1 on the x, and y is 0 right here. So f of 1 is 0. Find f of 4. Well, go to 4 on the x-axis. 1, 2, 3, 4. And y is up there. Y is positive 5. So f of 4 equals 5. Now these next few, same thing, just opposite. They're basically telling me what y is. They're saying find x when f of x is negative 1. So I have to go to where y equals negative 1. Remember, over here, f of x is aka y. So where y is negative 1, which is here, I have to find x. So it looks like x is 2, where y is negative 1. Find the value of x when f of x equals 0. So go to where y equals 0 and find the value of x. Well, y is 0 all along here, and wow, x has quite a few values here. X is negative 1, positive 1, and 3. So and that is possible again. Find where y is 0, x actually has 3 values. That's why I had to answer all 3 of those. Now find the value of x where f of x is 1. So where y equals 1 is up 1 here, and there it is. There's x. So where y equals 1, x is actually 0, you guys. Again, it's just up 1 space. It didn't go right or left at all. So again, where f of x equals 1 is here and x is 0 there. Same thing on this one. So I'm going to use the graph to find these values of whatever's requested. So find g of -3. Well, go to -3 on the x-axis, right? These are all x's, these values, and then these values will be the y values I looked up. So go to -3 on x, 1, 2, 3, and it's here, and y is over here when x is -3, aka f of x is here. So that is -4, you guys. -4. G of 1, so go 1 to the right, and there it is, it's 0. And then g of 0, well, g of 0 is here, and there is a point exactly in the middle, so where x is 0, y is also 0. Find the value of x when g of x is -4. So now I need to go to the y-axis for -4. And we actually already have that because it was there, but we'll just look it up again. So where y is -4, you would go down 4, or where, remember this is y, same thing as y. So go to -4, and then x is, here x is -3 at that point. And here's how you know it's -3, because it's 1, 2, 3 to the left. Find the value of x when g of x equals 2. So when y equals 2, let's see what that is. So y equals 2 would be up 2, and there's my x value, 1 to the left, so it's -1. Remember, leftward movement is from the origin is a negative value for x. Move to the right from the origin, that's a positive value for x. Let's see, find the value of x when g of x equals 0. So when y equals 0, again, we already looked this one up. When y is 0, I'd be on this axis somewhere. And let's see, actually x has multiple values there, though. X has, let's see here, 1, 0, -2, and -4. So x has multiple values. Look at all these points where the graph crosses the x-axis. X has multiple values where y equals 0, or where g of x equals 0. So all those values are good. And then just to kind of look back, so where y equals 0 here, x has all these values, but where x equals 0 is here. Okay, so where x equals 0, y only has one value. So just kind of wanted to point that out. So where x is 0, y is 0. X is 0 here along this whole line. There's only one value of, that crosses right there. However, when y is 0, it's all across this axis. So, or sorry, I have it backwards, but either way, where, or no, we're good. So where y is 0 is all along this axis, and where y is 0, we have 4 points. So we have to label all those values of x where y, aka where g of x equals 0. Just a few thoughts to summarize, but basically you can read them yourself. But either way, just kind of a reminder of these few things. And anyhow, just on this last one, remember when you do calculate using function notation, you really just do the work on the right side. So on the left is just notation, and on the right is where I actually do my calculations. So don't forget that part.